Hello everyone, in this video I would like to show the mesh generation and the optimization scheme of the FEA models. So in this video I would like to specify the element shape, type and sizes, and mesh the whole assembly. And we would like to create the job and submit job and monitor the job when it's running, and assess the mesh by checking the results briefly. And finally, I would like to show the mesh optimization scheme, including the mesh size, element type, and the shape. So let's get started. Imagine if we have already got the model, and we check everything is okay before excluding the mesh. So you can check there is mesh where there is material definition, step definition, assembly definition, everything is okay, and including the contact, including the boundary conditions and the loads as well. Okay, let's move to the mesh modules. So basically we would like to apply the mesh control first to select all of them, all of the parts. Firstly, we would like to use the triangular mesh type and choose the element type and use the shift to continue to select. And currently we use plain string and triangular hybrid formulation. So CPE3H, the code is for the element type. So we can use the CSS to seed all of the lines within the assembly. Click OK. So OK, keep the default, but we can assign the size roughly 1 millimeter. Okay, so we can select the mesh, and we would like to mesh the assembly roughly. Okay, so totally there are 28,000 elements generated, but it's rather rough and rather coarse. Okay. And we can choose different element types. For example, we can use the control to select all of them to remesh it with quadrilateral elements. And accordingly, we need to choose the quadrilateral element type. Use that one, and use hybrid or not. I prefer using non-hybrid. So CPE4R for that one. I select all of them and remesh it similarly. Okay. Now I would like to use the triangular one. Currently it shows the quadrilateral mesh, but I prefer using the triangular one. Okay, let's go back and delete it. Redo the same things. Okay, CPE3H is a plain string. Okay, so we got the mesh now. We can check briefly, it's roughly okay because it's rather uniform. So we can create a job, and we can name it a coarse mesh or coarse. In the description, okay, it's basically sold with coarse mesh. I'll keep the default value, right click it, and we can use something, but basically we just submit that one. And if the job exists, we just ignore that one. There should be a window opening pop up. Yeah, we can right click it and monitor. We can monitor the job when it is running. So basically this is the monitor of a job, and there are some informations there are logs, errors, warnings, output data file of the running job. Don't panic if there is any warning message. If there is no error message, it should be fine to run it. And there are some message file containing some information. If you would like to have a better understanding, just ask me about details. So basically, if there is a complete input file, so should be fine in the log. So basically, it's running. You see there is a completed analysis input file processor. So basically, it says our model is generally fine. Let's see what's going on, and the job running. Okay, it's running, but it's a bit slow. You can see we can monitor the step, the time increment. Currently, is rather tiny because at the very beginning, it's rather tough, struggling to run to solve the problem. Okay, let's see. Let's wait. Don't worry. I believe you should have a better CPU than mine. So basically, I increase the speed, speed up the video to make it faster. Okay, so until here we finish the first step. We can see here, and it starts the second step. So you still remember 0.1 is the total time step we assigned to the first step, and now it's running the second step now. So now it should be fine. We can monitor it, and it takes some time to finish. The time is dependent on your CPU and memory. Okay, let's speed up. It's running. Okay, roughly. Hurry up. Okay, so the total time should be 35 seconds for the second step. So we just wait for the final increment span of the second step. Okay, so it's done. It says completed. Okay, that's cool. So let's see what's going on in the results. So there are some warning, but should be fine. Okay, right click to see the results, or alternatively you can use the results viewer to open the ODB file there. Okay, so plot the counters on deformed form. Okay, here we go. Okay, we can see the stress distribution in the assembly. There's some stress concentration, and we can translate. We can use the back arrow to see where is the evolution of the stress. But basically, we can use the contact pressure to evaluate how the mesh works. So basically, if we would like to select the contact pressure along one of the gear teeth of the pinion. Okay, let's select the pinion only. So, and I would like to show you the path definition along that teeth. So we define that path, and after select one by one by holding the shift. Yeah, one by one. Yeah, from the external surface of the gear teeth until the fillet. Okay, that's it. Okay, select OK, and we can plot the contact pressure. We just select the path here, and we can choose path 2, the path we define, and select the field output as the contact pressure. Okay, we can see there's only one point involved. There is a very sharp peak instead of the desired shape. So you can see, okay, there one value is very huge, and okay. So basically, our mesh is roughly two calls. We cannot capture the details of the distribution of the contact pressure with that coarse mesh. So basically, we need to refine the mesh, and I will show you shortly. So basically the mesh is quite coarse, especially when they are in contact. So let's refine the mesh for the gear teeth. So we can copy the model and rename it. Okay. And go to the mesh module, and we can redefine the mesh now. So basically we need the partition scheme. So basically we would like to use different mesh size in different regions. So basically, for example, I would like to do the mesh optimization in the pinion. So basically, we just focus on the pinion. Select pinion. Okay, just the pinion now, and we can do the partition now on the part of the pinion. So just focus on the third and the fourth teeth now. So select the partition here. Yeah, we like to do the partition in the part. We just ignore. We just delete the original mesh. Okay, here, and we need some construction lines. Okay, we'll create one construction line here. Second one here. Define that one because it's construction line, so should be fine here. Another one, there we go. Okay, we miss one, and we need to add another construction line at the left. Okay, there we go. So now we have the partition now. Oh no, not finished yet. So you need to define the lines, the solid lines. Okay, use with the aid of the partition. Okay, and then roughly we have the partition. Yeah, the solid line here. Okay. And we use the arc. Okay, constrain another to create another region partition. Yep. And we just to close it, but yep. Use solid line to link point teeth surface, teeth size. Okay, so roughly something like that one. So we can assign different mesh size to the specific region there. So we can select the global one to even rougher, even large element size to that. To all of the valued, and for the gear teeth, we would like to apply a high density there, mesh density here. We can select number, we can select uniform one, but 200 elements there. So okay, we got it. We can check the C's after applying the density there. Okay, next one is about the external surface of the teeth. Use Shift to hold it, to select them all, and we can assign biased C's. Basically, is the higher density to bring it closer to the teeth size. Okay, we can flip. We can select the side to flip the bias ratio. Okay, a bit tricky. Yeah, and select a proper value for the bias ratio. Okay, so let's say 10 here, and for the bias ratio about 5 something. Okay, let's see. And okay, we need to do that one as well. Okay, we have done the external surfaces, and we need to do the fillet as well. So we see the fillet now. We are seeing the okay, we can see that one as well. Design the bias ratio as well. Okay, and we can track it roughly. So basically, they are compatible at the adjacent regions. Okay, nice. The fillet sections. Use Shift to select all of them. Totally 4 sections there of the fillets. So we can select number. It can be uniform. Roughly select size at 0.05, I think. Yep. I see, and we can check roughly. Okay, the seeding is fine, roughly fine. Okay. And now let's move on to the parts next to them. I think we can select the bias ratio as well here. We can specify the seeding method by size or by number, depends. And we select all of the segments there, here. Okay. Roughly 0.5. Okay, it's uniform here. Okay, and we need to do next as well. Following 5, and we can apply a bias there. Okay, the fillet direction, the bias direction is okay now. Okay. Select OK. So we have finished the seeding of the partition now, and we can remesh it. Okay, let's see what's going on. Okay, select all of them and mesh it. Okay, now we can see we have a finer mesh, especially at the region of the contact, actually the gear teeth. But I mean, on the other region is roughly fine. So we can use the verify to check the mesh quality roughly. And there's okay, so use that one to highlight the U shape of elements if there are any. Okay, let's see. Okay, roughly, so the mesh is generally okay. So we can use that one to discretize the pinion, and we need to do the similar strategy on the wheel as well. Due to the time, I wouldn't like to show it here. You can do that as well, and we can resubmit to check. So let's summarize the video here. So the operation in this video begins with the assembly of the pinion and wheel. If you have any problems, just go back to check the video 2. Now we should be able to discretize the assembly now, and we should be able to assess and roughly optimize the mesh by checking the results. In particular, the contact pressure distribution along the contact teeth. We will be able to post-process and analyze numerical results of the model with the refined mesh after video 4. So Thank you guys for watching. See you in video 4.